Hello student, welcome to maths class and today we'll do number play. Our learning objective in this chapters are numbers can tell us things, patterns of the number in the number line, playing with digits, it's pretty palindromic numbers, supercells, clock and calendar number, mental maths, and unsolved mystery of the college conjugator, games and the winning strategy, the magic number of Carpenter, playing with the number pattern and simple estimation. So all these things we are going to learn in this chapter. We'll start with the introduction. Number play a vital role in many aspects of our life, helping and organizing make the sense of the world. We use them to count and apply the basic operations such as addition, subtraction, multiplication and division to solve everyday problems. So in everyday life we use numbers. In this chapter we will explore number further, engaging with them in a new way, discovering the pattern and experimenting with the different operations. The journey will help us to see how numbers surround us and support in daily activities. First is number can tell us things. Number help us to count objects and compare groups, showing which collection is larger or smaller. So by using number we can compare two groups and allow us to arrange items in sequence like first, second and so on. Numbers also help us to explore patterns, relationship, the key aspect of the world including type of even, odd, prime, composite as well as fraction and decimal. Next, pattern allow us to predict what comes next. So pattern and help us to know what will come the next, and are found in areas like art, music and science. Even odd numbers are essential for division and multiplication and are commonly used in everyday tasks like sharing item equally. So in all these things we use numbers. So prime numbers act as the foundation of the other numbers, while fraction and decimals are useful in daily life, whether measuring ingredients in the cooking, calculating cost when shopping. So in all these things what we are doing? We are using numbers. Next we will take supercells. So what are the supercells? The cells is called the supercell if the number is greater than the number in all of its neighboring cells. For example, consider the grid. If we take this shaded grid, the number on the both sides of this grid, they are smaller than this number. So 7 is greater than 4 and 6 both. So in this grid, 7 is the supercell because it is greater than the neighboring numbers 4 and 6. 8 is the supercell because it is greater than 6 and 3. 9 is the supercell because it is greater than 3 and 5. Thus 7, 8 and 9 are the supercell in this sequence. Now we will take some solve examples. Example 1. Color and mark the supercell in the table below. So we have to color the supercell. Solution. Which is the supercell? This is the supercell because it is more than their neighboring number. That is here. This is also the supercell. Like this we have to mark in color. Clear? Next. Fill the table with only 4-digit numbers such that the supercell are exactly the color cell. So this is solution. This is how we'll fill the number and make it supercell. Like here 8345. This is greater than 5346 and 1173. This like this we can make many supercell. Next is fill the table below such that we get many supercell as possible. Use the number between 100 to 1000 without repetition. So we have to make as many supercell we can make. We have to take number between 100 to 1000 without repetition. So here we'll take number between 100 to 1000 like 999 in 573, 650, 633. So here you can see this is supercell because it is greater than 573 and 633. Like this we will write the number. Clear? Next example. Fill the table such a way that the cell having the second largest number is not the supercell. So here 980 is the second largest number, but it is not the supercell, because 999 is the supercell because it is greater than that. Clear? Next, example 5. Fill the table such a way that the cell having the second largest number is not the supercell, but the second smallest number is the supercell. Is it possible? Here, 1870, that is the second largest number, but the cell having 1870 is not supercell because the number 1895, adjacent cell, is greater than it. 489 is the second smallest number, but 489, that is the second smallest number, but it is a supercell because it is greater than its adjacent cell. Clear? Next is learning point 3.1. So you have to practice all these questions of this exercise. These are based on the concept we have covered in the chapter. Clear? So practice all the questions. Next is patterns of the number on the number lines. The number line is a visual tool that shows the number along the straight line, making it useful for comparing and ordering them. It also helps illustrate basic arithmetic operation. To use the number line, we can essentially understand how to place number accurately. So we have done previously how we can add and subtract or multiply the number using number line. The center point of the number line is 0, the positive number, such that the natural number are positioned to the right of 0, while negative number are placed to the left. Moving left along the line decrease the number value. For instance, 1 is greater than -2. So this is 0, that is the center of the number line. As you move right to the number, all the positive number. As you move to the left, all the negative number. Now we'll take an example. Place some numbers in the appropriate position on the number line. Here are the numbers. So here we can see 1000, 2000, 3000, 4000. So we have to place these numbers. Is 2180, 2754, 1500. So this is 1050, this is 1500, because this will come between 1000 and 2000. Like this, you have to place the number. Clear? Next example, identify the number marked on the number line below and label the remaining position. So here we can see the number marked. First, this is 2010 and 2020. So 2010 and 2020, what will come between? 2015. So we'll start with 1190, then 1995, 2000, then 2005, 2010, 2015, 2020, 2025, 2020, 2035. Clear? Like this. Here also we'll mark the number like this. 9996 and next is 9997. So difference of 1. Start. Now here it comes 9995, 9994, 9993. Like this will mark the number. Clear? First we'll see the sequence and accordingly we'll mark the numbers. Clear? Next, playing with digits. Digits are a single number from 0 to 9 that combine to form the larger number. They serve as the building block of all numbers. The digit sum of the number is the total when you add up each of its individual digit. For example, in a number 345, the digits are 3, 4 and 5. Their sum is 3 plus 4 plus 5, that is 12. Next is building numbers. First, without repeating the digit. To form the greater number, we always place the highest digit at the extreme left of the number and place other digit in the descending order. To form the smallest number, we will start with the smallest digit at the extreme left of the number and place the digit in ascending order. Clear? Next, by repeating the digit, here we are repeating the given digit. To form the greatest number, we will place the greatest digit maximum time from the extreme left. So, which digit will repeat? The greatest digit, maximum number of time. Clear? From left of the number and place all the other digits in descending order. To form the smallest number, we place repeat the smallest digit. Here we will repeat, because we have to form the smallest number, we will repeat the smallest digit maximum time from extreme left of the number and place all the other digit on ascending order. Easy tip. If 0 is placed as extreme left, the resultant number will be one digit less, because if you start a number with 0, the number will be one digit less. So 0 is always placed in second place from the extreme left. Now we will take some example here. Find how many numbers have 2 digit, 3 digit and 4 digit and 5 digit. So 1 digit number 1 to 9, total 9 numbers. 2 digit numbers from 10 to 99, 90 numbers. 3 digit 100 to 999, total 900 numbers. Then 4 digit numbers, total 9000, and 5 digit, total 90,000. Clear? Next example, digit sum of 14. Write other number whose digit add up 14. What is the smallest number whose digit sum is 14? What is the largest 5 digit whose digit sum is 14? How big the number can the form having the digit sum 14 can you make our even bigger number? So we have to answer all these questions. So number whose digit sum is up to 14, that is 59, 9 plus 5, 14, 68, 6 plus 8, 14, 77, 7 plus 7, 14, like this. The smallest number whose digit sum is 14, that is 59, 9, 5, that is 14. The largest 5 digit number containing 0 whose digit sum is 14, that is 95,000. 9 plus 5, that is 14. The largest 5 digit number not containing zeros whose sum is 14, that is 92,111. 9 plus 2 plus 1 plus 1 plus 1, total 14. A very big number having the digit sum 14 can be made by using these digits. An even bigger number we can make adding 0 as much. So yes, we can make the even bigger number. Next example. Find out the digit sum of all the numbers from 40 to 70. Share an observation with the class. So 40 digits are digit sum 4 plus 0 4, 41, 4 plus 1 5. Like this, we'll find the digit sum up to number 70. Clear? Next example. Calculate the digit sum of 3 digit numbers whose digits are consecutive. For example, 345, 3, 4 and 5 consecutive numbers. Do you see the pattern? Will this pattern continue? Like 123, 1 plus 2 plus 3, 6, 234, 2 plus 3 plus 4, 9, 345, sum is 12, 456, sum is 15, 567, sum is 18. So, you can see a pattern is following here. Yes, we observe the pattern. First number plus 1 into 3, that is equal to digit sum. Clear? Next example. Write all the 3 digit number using the digit 254. The digits are to be used only once. So we have to use the digit only once. We are not going to repeat any digit, and we have to make all the possible 3 digit number, keeping 2 at the 100 place and 3 at the number 254, 245. Now we'll keep 5 at 100 place. 3 digit numbers are formed 524 and 542. 4 at 100 place we can make 425 and 452. Therefore, 3 digit number using the digit 2, 5 and 4 are 254, 245, 524, 542, 425 and 452. Next is learning point 3.2. So, practice all the questions given in this exercise. Next is pretty palindromic pattern. What are palindromic number? A palindromic number is the one that read as the same both forward and backward. Whichever way we will read the number same. For example, if we take this number 2,85,582, that is the 6 digit palindromic number. If we read it this way, I'll read it same 2,85,582. If I start from here, I'll read it same 2,85,582. Clear? The first 30 palindromic numbers are as follow: 0, 1, 2, 3, 4, 5, 6. So, first 30 palindromic numbers are given here. Next, reverse and add palindromes. This intriguing process involves reversing the digit of the number, adding these reverse numbers to the original number, and checking if the result is a palindrome. If the result isn't the palindrome, the process repeated till the new number until we get a palindromic number. We'll take an example here for the number 21. So, 21. Now we'll reverse the digit. It becomes 12 and their sum is 33. 33 is a palindromic number. Now we'll take an example 56. Now 56 plus 65, that makes 112, which is also a palindrome. Petty palindromic patterns are visually appealing, symmetrical sequences that are the same forward and backward. They often use the number, letter and other symbols in the mirror layout, creating pleasant and balancing aesthetics. Next is numerical palindromic patterns. In numbers, palindromic patterns is the sequence of the digits read the same from left to right and right to left. These patterns can be crafted to create stunning mirror-like structure or with repeating numbers. For example, single line numerical palindrome 121, 12,321, like here, 12,34,321. So, each of these patterns reflect around the center, creating a balance on the either side. Next is triangular number palindromic pattern. So, in triangular number you can see the palindromic pattern like this: 1, 121, 1, 2, 3, 2, 1, like this. Next is alphanumerical palindromic pattern. Palindromic pattern can also be created with the letter where the sequence remain identical in both sides. For example, single line letter palindrome like A, AB, A, B, B, A, A, B, C, B, A. So, these make a palindrome. Each letter form a palindrome with the center letter expanding symmetrically outward. Letter pyramid patterns like here: A, A, B, A, A, B, C, B, A, A, B, C, D, C, B, A. Similar, the numerical triangle. This pattern uses letter to grow outward, achieving symmetry through the center peak. Now, we will take some example. Write all the possible 3-digit palindrome using the digit 1, 2, 3. So, solution: 111, 121, 131, 212, 222, 232, 313, 323, 333. All these are palindromic number. Example 2. Will reversing and adding numbers repeatedly starting from the 2-digit number always give a palindrome? Explore and find out. So, we have to find whether by reversing and adding the number we always get a palindrome. All the 2-digit number eventually become palindrome after repeated reversal and addition. About 80% of all the number under 10,000 resolve into the palindrome in 4 or fewer steps. About 90% of those resolve in the 7th step and fewer. For example, if we take number 12, initial number is 12, reverse, if we reverse the number we will get 21, 12 plus 21 will get 33. So, that is a palindromic number. If we take another number 89, reverse the number we will get 98, 89 plus 98, 187. Now, 187 is not a palindromic number. So, we will repeat this process, 187, and we will reverse the number 781, we will get 968. Again, this is not a palindrome. So, we have to repeat the process until we will get a palindromic number. The magical number of Karpikar. Karpikar's magic numbers, also known as Karpikar's constant, that is 6174, discovered by the Indian mathematician D.R. Karpikar. It is the result of fascinating process when applied to any 4-digit number with at least 2 different digits. Here is how it works. How it works? Karpikar's process. So, for that we will choose any 4-digit number with at least 2 different digits. Like here we have taken 3524. Now we'll arrange the digit in descending order and ascending order to create a 4-digit number. So we'll make a greatest number and smallest number. Descending order 5432 and ascending order 2345. Now we'll subtract the smaller number from the greater number. So it will give 3087. Now we will repeat the process and the result 3087. After a few iteration you will reach the number. So if we keep repeating this process, after some step we will reach the number 6074. Clear? And repeating the process 6174 will always bring you back to 6174. For example, start with 3527. Now we'll make the greatest and smallest number using these digits and find their difference, that is 3087. Now again we'll repeat the process, we'll make smallest and greatest number and find their difference, and if we repeat the process we'll get 6174, which is the magic number of Karpikar. Clear? This number 6174 is Karpikar constant. It is unique because for any valid 4-digit numbers following this process will always end with 6174 in the maximum of 7 steps. Next, let's say take some example here. Take different 4-digit numbers and try carrying out these steps. Find out what happened. So here we'll select 4-digit number, that is 1234, starting with the number 1234. Descending order 4321. If we'll arrange the number in ascending order 1234. We'll find the difference, that is 3087. Now we'll repeat the process. Now here the sum is 8352. Again we'll repeat the process and we'll get 6174, which is Karpikar constant. So you'll see how amazing this is. After few steps we always reach to Karpikar constant. That is the magic of Karpikar constant. Now we'll take example 2. Carry out these same step with a few 3-digit number. What number start repeating? So now we'll try this process with a 3-digit number. Here we have taken 3-digit number 123. We will make the greatest number 321 and smallest number 123. Their difference is 198. Now we'll repeat this process. Here the difference is 792. We'll keep repeating this process like here. So we keep repeating till this much. But what is the result? The result number is 495. Start repeating. When apply Karpikar routine with 3-digit number, the number is 495, which is often reached. Start repeating. This number is known as the Karpikar constant for 3-digit numbers. So this is 495. That is the Karpikar constant for 3-digit number. Clear? Next, we'll take an example. How many rounds does the number 5683 take to reach the Karpikar constant? So again the process will be same. With given digit we'll make the greatest number and smallest number and find their difference. We'll keep repeating this process. So at the end of round 8 we will get the Karpikar constant, that is 6174. Next, clock and calendar numbers. A palindromic time or the symmetrical time is one of where the minute are the mirror image of the hour in the Ajit format. For instance, 12:21 or 2:20. These are the palindromic time. Reading these time from left to right and right to left give you same result. Similarly, palindromic dates are the dates which read the same from forward to backward when written in the particular format. For example, 2 February 2024 is the classic palindromic date. Like MMDDYYYY format, it reads identical in both the direction. Clear? Now we'll take some solve example. Example 1. Try and find all the possible time of 12-hour clock to each of type for the example 4:44, 10:10, 1221. So that is 110, 220, 330, 440, 550, 10, 1, 11, 11, 12, 21. All these are palindromic time. Now we'll take one more example. Find some other dates to form this format. The past like 2012, 2012, where the digits 2, 0, 1 and 2 repeat in the order. So solution like 11 to 2011. So 12 to 2020, 1 10 2010, 10 1 2010, 2 2 2020. Now we'll take example 3. Ruchi uses the digit 4, 7, 3 and 2 to make the smallest and largest 4-digit number with them. 2347, that is the smallest, and 7432, that is a greatest number. The difference between these two numbers is 5085. The sum of these two numbers is 9779. Choose 4-digit to make the difference between the largest and smallest number greater than 5085. The difference between the largest and smallest number less than 5085 and the sum of the largest and smallest number greater than 9799. The sum of the largest and smallest number is 9079. So in first case, the difference between the largest and smallest number greater than 5085. So largest number, that is 8732, smallest, that is 2378. Difference is 6054. Clear? Which is greater than 5085. In the second case, digit 1, 2, 3 and 4. So largest number 4321, smallest is 1234, difference is 3087, which is less than 5085. In next case, we have taken the digit 9, 8, 7 and 6 will form the largest and smallest number, and the difference is, now we have find the sum, that is, we have find their sum, which is 16,685, which is greater than 9,779. In next case, we have taken the digit 1, 2, 3 and 8 will form the largest and smallest number, and their sum is 9,589, which is, so in this case 5,559, which is less than 9,779. Clear? Next example. What is the sum of smallest and largest 5-digit palindrome? What is their difference? So smallest 5-digit palindrome, that is 12,321, and largest 5-digit palindrome, that is 98,789. Their first, their sum, this is the sum, and their difference. In case 2, largest 5-digit palindrome, same, that is 999999. So that is 99,999. Smallest 5-digit palindrome, that is 11,111. We can find their sum and difference. Clear? Next, example 5. The time now is 10:01. How many minutes until the clock show the next palindrome time? What about the one after that? So time now is 10:01. Next palindrome, that is 11:11. So difference in time is 70 minutes. After 70 minutes, it will show the next palindromic time. Next is learning point 3.3. So you have to practice all these questions given in exercise. Next is mental maths. Using different combination to achieve the same sum of difference is the powerful mental maths strategy. This approach is not only strengthen arithmetic skills, but also encourage flexibility in the thinking about the numbers. Here are a few examples for how we can break down numbers in various ways. Example of using different combination for mental maths. To get 10,000, we'll make different combination. 5,000 plus 5,000, that is 10,000. 6,000 plus 4,000, that is also 10,000. 3,000 plus 3,000 plus 4,000, 10,000. 2,000 plus 2,000 plus 2,000, 5 times, that is 10,000. So you can see by making different combination, the sum is same, 10,000, but using different numbers. Same way, to get 75,000, 50,000 plus 25,000, that is 75,000. 25 plus 25 plus 25,000, that is also makes 75,000. So making different numbers, we can get the same number. To get 120, 60 plus 60, 120, 40 plus 40 plus 40, 120, like this. By adding different number, we can get the same numbers. Same way, to get the 1,000, 500 plus 500, 1,000, 600 plus 400, 1,000. So you can see we can make different combination to get the same numbers. Next, benefit of using different combination in mental maths. Flexibility, help to seeing the number in various part which can simply calculation. Speed makes it quicker compute the large number by breaking them down into manageable parts. So we can quickly count or compute it. Problem solving encourage creative problem solving, useful in everyday scenario involving budget, distance and other numerical calculation. Now we will take some example. Write example for each below scenario where possible. 5 digit plus 5 digit to give the 5 digit sum more than 90,250. So let's divide 45,125 and 51,873. Here we have divided the given number by 2 and we'll get 45,125, and we'll take another number 51,873. Their sum is 96,998. Clear? The sum should be more than 90,250, like this. Clear? In this case, to get the 6-digit sum by adding 5-digit and 3-digit number. So we'll take the number that is 99,001 and 999. So the sum will be 1 lakh. That is a 5-digit number. Clear? Let's take minimum 4-digit number, that is 1,000. Let's add them. 1,000 plus 1,000, that is a 2,000. Hence 6-digit sum of 4-digit number is impossible. In case D, let's take 5-digit number. Here we have taken this 5-digit number and this. We'll add them. So we'll get a 6-digit numbers. Clear? In next case, let's take the minimum 5-digit number. That is 10,000. Add them together, we'll get 20,000, which is a 5-digit number. Hence 6-digit sum of 5-digit number is impossible. Clear? So this way we can take the different combination and can find whether that is possible or not. Clear? Next is always, sometime and never. So we have to see whether this combination can happen or not, or give the result or not. Below are some statements. Think, explore and find if each of the statement is always true, only sometime true or never true. Clear? Like 5-digit plus 5-digit numbers gives a 5-digit number. So sometime, in this case you can see sometime it can happen, but not always. 4-digit plus 2-digit number can 4-digit number, sometime can happen but not always. 4-digit number and 2-digit number gives 6-digit number, never. Because here we have taken the largest 4-digit number and largest 2-digit number, but that is not a 6-digit number. Clear? 5-digit number and 5-digit number gives you 5-digit number, sometimes true but not always. 5-digit and 2-digit numbers gives a 3-digit number, that not possible. Next, playing with number patterns. Number patterns are essential in mathematics as they build foundational skill in recognizing relationship and applying logical thinking. Identifying patterns help students to develop problem solving skills and intuitive sense of the number relationship. Common type of number patterns. First is arithmetic patterns. These patterns involve the sequence where the constant number is added or subtract to each term. For example, 3, 6, 9, 12, 15. Every time we are adding 3 to the previous number to get the next number. Next is geometric patterns. In the geometric pattern, each term is multiplied or divided by a fixed number to get the next term. Like 2, 4, 8, 16, 32. Multiply by 2 each time to get the next number. Next is square or cubic pattern. The pattern is based on the square number like 1, 4, 9, 16 or cubic number like 1, 8, 27, 64. Show the number raised to the power 2 or 3. There are patterns are commonly used in geometry and algebra. Next is triangular pattern. These patterns use the triangular number which form the triangle when represent as dot. When we arrange these numbers, they will form a triangular pattern. For example, 1, 3, 6, 10, 15. So, each term is the sum of the first natural numbers. Next is Fibonacci sequence. Fibonacci sequence. The unique pattern where each number is the sum of two preceding numbers like 0, 1, 1, 2, 3, 5, 8, 13, 21 like this. Next, we will take some example. Example 1. Find the next terms in the sequence 15, 21, 27, 33. So, first we will find the pattern. The pattern adds 6 to each time. So, next number will be 33 plus 6, 13, 9. Next example. Find the next term in the sequence 5, 10, 20, 40 like this. So, pattern multiplied 2 by each time. So, next term 40 into 2 that is 80. Example 3. Find the next term in the sequence 1, 1, 2, 3, 5, 8. The pattern at the previous two term, the next number will be or term will be 5 plus 8 that is 13. Next example, example 4. Find out the sum of the numbers that one by one or can we use the quicker way. Share the discuss the class the different method each you use to solve these questions. So, here what you can do, you can count how many times 40 is there because you can see the numbers here are 40 and 50. So, what you can do, you will take 40 and how many times 40 is there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, 12 into 40. And how many times 50 is there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. 10 into 50. And the number you will get, you will add them together and find the sum. So, here you can see in figure A, the number 40 is repeated 12 times and the number 50 is repeated 10 times. So, 40 multiplied by 12 plus 50 multiplied by 10, that is equals to 480 plus 500, 980. So, this way we can easily find out the sum. In next question, in figure B, 1 dot is 44 times and 5 dot this kind are 20 times. So, total number of dot 1 into 44 plus 5 into 20 that is equals to 144. In figure C, the number 32, here you can see the number 32, it is 32 times, 32 is repeated 32 times and number 64 is repeated 16 times. So, 32 multiplied by 32 plus 64 multiplied by 16 that is equals to 1024 plus 1024, total is 2048. In figure D, this is the figure D. Here you can see 3 dots are 17 times and 4 dots are 18 times. So, what we will do? 3 multiplied by 17 because 3 dots are repeating 17 times plus 18 into 4. Total is 123. Similarly, in figure E, the number 15 that is 22 times. So, what you will do? The which number is repeated how many times? You will count the number and multiply it. So, number 15 is repeated 22 times. So, 15 into 22 plus number 25 is repeated 22 times. So, plus 25 into 22 and you will find the sum, and here 35 is repeated 2 times. So, 35 into 22. You will find out the sum and add them together. So, total is 1650. In figure F, this figure. In figure F, you can see the number 125 is repeated 18 times, and 250 is 8 times, and number 500 is 4 times, and number 1000 is 1 time. So total sum, that is equals to 125 into 18 plus 250 into 8 plus 500 into 4 plus 1000. Total is 7250. Clear? Next is an unsolved mystery of Collatz conjugal. The Collatz conjugal is known as the 3x plus 1 problem in one of the most famous unsolved problems in mathematics. It's a simple yet perplexing problems that has baffled mathematicians since it was proposed by the Lothar Collatz in 1937. You can see how old this problem is. Still it is unsolved. It is a mystery for mathematicians. Despite its simplicity, no one has been able to prove or disprove it for all the positive integer, making it the fascinating topic in the mathematics. So let's see what is the unsolved mystery of Collatz conjugal. The Collatz conjugal explained. The conjugate involved the sequence defined as follows. Start with any positive integer n. If n is even, so if n is even, we'll divide it by 2. If n is odd, we multiply by 3 and add 1. Repeat this process with the resulting number. The consequence states that no matter which positive integer you start with, the sequences always eventually reach the number 1. So no matter with whatever number, with whatever positive integer you start, you always reach at 1. So let's understand it with example. So we'll starting with the number 6. 6 is what? 6 is a even number. Clear? So we'll divide it by 2, we'll get 3. Now 3 is odd number. So what we'll do? We will multiply it by 3 and add 1. 3 3s are 9 plus 1 10. We'll keep repeating this process until we reach 1. So here we reach 1. Suppose our number is 11. The same process, 11 is odd number. So multiply by 3 and add 1. 11 into 3, 33 plus 1, 34. 34 is even number. So we'll divide by 2, we'll get 17. Now 17 is odd number, we'll multiply by 3 and add 1. We'll keep repeating this process and at the end we will reach 1. So the sequence eventually reach 1 and then enter the cycle 4 to 1. Now why is the Collatz conjugal so mysterious? Simple definition, complex behavior. The rule for generating the sequence are straightforward, but the behavior of the sequence is unpredictable. Some number quickly reach 1 while other seems to take many steps to grow larger before they finally do. So with some number we reach at 1 quickly, but some number take so much time, so many steps are there and it's very long method. Next, no proof yet. Mathematicians have tested the conjugal for the number up to extremely high value and find out. So mathematicians try these rules for extremely high values and they found that it holds true, but the formal proof that it works for all positive integer remain elusive. So they have tried for very high value and they found that it holds true, but not always, like it work for all the positive integer or not, that is still not sure. Next is apparent randomness. While it always seems to converge to 1, the path it takes can vary widely and there is no clear pattern to explain why it works universally. The problem is deceptively complex. The problem is deceptively complex, blending element of number theory and dynamic system. That's why it's still a mystery. Next, the Hailstone sequence. What is the Hailstone sequence? The sequence generated by applying the Collatz rule is sometimes called the Hailstone sequence because of the way number bounce up to down unpredictably before finally falling to 1, like hailstone rising and falling in the storm cloud. That's why it's called a hailstorm sequence. Next, why does the Collatz consequence matter? Although it seems like a simply curiosity, for the Collatz consequence has connection to the various fields of mathematics, including chaos theory, dynamical system, and the computation mathematics. It challenges our understanding and number behavior and randomness in the mathematical sequence. So, with Collatz consequence, you can apply this to see the behavior of number, how they behave unpredictably. Next is attempt and progress. Numerous mathematicians had made partial progress, proving the consequence the specific sets of number or formulating equivalent problem. However, the complete solution remain out of reach. The consequence has been tested computationally for the numbers up to at least 1020 and no counter example has been found. That's why it's still a mystery. Next, final thoughts. The Collatz consequence is an excellent example of how simple question can lead to the deep and unsolved mysteries. It continued to inspire mathematicians and enthusiasts alike, who wonder if there might be some hidden pattern of insight waiting to be discovered. So, still mathematicians trying to solve it and trying to apply it for the more bigger and bigger number. Now, we will take some example here. Here we are starting with the number 7. Now, we are trying Collatz consequence. Clear? So, number 7 is an odd number. So, multiply by 3 and add 1. So, we will get 22. Now, 22 is an even number. So, we will divide by 2. We will get 11. 11 is odd number, multiply by 3 plus 1, 34. We will keep repeating this process. And at last here we get 1. So, starting from the 7, eventually we reach 1 after 16 steps. So, this method is very long. One more example, starting with the 15. 15 is odd number, so multiply by 3, add 1. So, we will get 46. 46 is an even number, divide by 2. We will get 23. 23 is again odd number, so multiply by 3 plus add 1. We will get 70. 70 is an even number, divide by 2, we will get 35. We will keep repeating this process, and here, starting from the 15, we reach 1 in 17 steps. So, to solve this problem, total 17 steps are required. Next is simple estimation. Estimation is the useful skill in everyday life, allowing us to make the quick and reasonable guess without needing the exact calculation. So, estimation gives us an idea. We cannot give the exact calculation or exact idea every time. So, we can just estimate. It could be around that number, but not the exact number. Examples of estimations. For example, sometimes we estimate cost. If you are shopping and see item price rupees 15, rupees 12 and rupees 8, you can estimate the total cost is around 35 rupees rather than calculating the exact total cost. So, it will give you an idea. Estimating weight, a watermelon may weigh around 5 kg, though its exact weight might be 4.8 or 5.2 kg. It could be more than that or less than that, but around that number. Estimating age, if someone looks young, you might estimate their age. Sometimes you look at the people and you say you look very young and you just guess the age. So, you are not giving the exact age. You are giving an idea or you are estimating the age. Estimating temperature. During summers, you might say it's about 30 degrees Celsius outside, even if it's actually 29.5 degrees Celsius or 30.3 degrees Celsius. Estimating length. If a book is roughly the length of the ruler, you could estimate it about 30 centimeter long. Estimation help us to make the quick decision, compare values and understand the scale of the thing without needing precise measurement. especially useful in the situation where the close approximation is all that needed. Let us consider an example. Mayank purchased a notebook for rupees 37, a pen for rupees 104 and a storybook for rupees 52. He wants to save time in making payment. Without doing the actual calculation, Mayank quickly estimated that it could cost around rupees 737 as rupees 40 or rupees plus rupees 104, because he has taken the estimated rupees 37, he has estimated around, he has rounded off that number to 40, 104 rupees 100 and 52 as rupees 50. The estimated price is rupees 190. 40 plus 100 plus 50, that is equals to rupees 190. What he has done? He has rounded up all the number and take estimated idea the cost would be around 190 rupees, whereas the actual price is 193 rupees. Thus, we conclude the estimation make our calculation easier and faster. It saves both our time and effort in dealing with day-to-day calculation. Estimate gives only the approximate value, that the value which is close to the actual value, not the exact value, it would be close to that value. Next, games and winning strategies. First is playing with the number, a strategy game. Here is a fun game called Reach 21. Play it with your friends, your family members and explore different winning strategies. Game Reach 21. Now we'll know how to play this game. To this game, the first player say either 1, 2 or 3. Then the player take turns adding 1, 2 and 3 to the last number called. Clear? So, the first player will say any number. Either it could be 1, 2 or 3. Then player take a turn adding 1, 2 and 3, the last number called. The goal is to the player who says 21 first, the player will win. So, you can play this game with your family members, your friends. Do try this game. Try this. Play several rounds with your friend. That can you spot the winning strategy. Which player has a guaranteed way to win if they play wisely? What number should the winning player say? So, you have to make a strategy for this game. What number you say so that you quickly reach 21. Game 2. Reach 99. How to play? The first player say any number between 1 to 10. Then the player take the turn adding the number between 1 to 10 to previous number. The goal is to player who reach 99 first. The player will win. The player who will reach 99 first, that player will be winner. Try this. Play this version few times with your friends. You can find the winning strategy. If you play again and again, you will understand how can you make the strategy to reach quickly on 99. Can you find the winning strategy for the game? Which player has the advantage? What sequence is the number should they aim to say so that they will quickly reach 99? That you have to find out. Create your own version. Make your own version of the game. Decide the winning number. Choose the range of the number each player can add each turn. So, like this, you can make your own game. Play your custom games few times and discover the best strategy to identify which player has the advantage. So, if you play many times, you will understand that which player has advantage, what sequences should be, what number you should choose, that you will understand. So, you have to make a strategy. Do try these games. Next is summary. Numbers of the multiple purpose, they help to convey information, reveal pattern, estimating size, create puzzles and develop winning strategy in game. Formulating method for using numbers in these way build the valuable skill known as computation skill. While some numerical problems are simple to state, they can be very challenging to solve. In fact, many such problems like Collet consequer remain unsolved. That you have read in chapter about the Collet consequer, how still remain a mystery for the mathematician. So, here we end the chapter. I hope you understand the chapter well. Now you to practice this chapter.